This is a revision video on transverse and longitudinal waves. A transverse wave is a wave that oscillates at right angles to the energy transfer. So for example, if the energy is going left to right in this example, the wave is going to be transferred perpendicular up and down at right angles. And we can draw a transverse wave like this, up and down. The particles are oscillating up and down, up and down. The energy is going left to right, energy going left to right, but the particles are oscillating up and down at 90 degrees at right angles. That's the definition of a transverse wave. A longitudinal wave is parallel to the energy transfer. So if the energy transfer is going left to right again, the oscillations are going to be left and right, parallel. And a longitudinal wave is represented with areas of compressions and rarefactions. So we've got compression, where the particles are close together, and we've got areas of rarefaction, where they're far apart. Longitudinal waves have to have particles. Longitudinal waves have to have particles. For example, sound. We can't transfer sound without particles, whereas transverse waves do not need particles. For example, light. Even though they don't need particles, they can use particles. For example, oscillations of water up and down on a wave at the beach or in a ripple. They're still oscillating, they're still transverse waves, and they are using the particles. It's important to remember that when we're talking about transverse waves or longitudinal waves, it's the energy that's being transferred. The particles are not moving. The particles are not being transferred along. They're not being the ones moved. So when water goes along a beach, it's the energy that's being transferred, not the particles themselves.